Okay, and this next question is a super tough question, question 21. And you can see it's the last question in the paper. It's only worth 3 marks. Okay, so as I said, unless you're trying to get 100%, don't get too stressed if you find this super difficult. Okay, let's first of all, we've got heads being thrown twice, and we've seen before that we can create a tree diagram. Okay, where you get one throw. Okay, so this is the first throw. Okay, where he gets a head and gets a tail. Then there's another throw. Okay, second throw. Okay, we get a head or a tail. Here we get a head or a tail. Okay, now this outcome would be giving you head. This would give you head, tail. This would give you tail, head, and this would give you tail, tail. And key word here is the word that shows head exactly, okay, once. Okay, so that's not a successful event. That is, but that isn't a successful event. Okay, so let's try and add some probabilities to this. Well, the probability that he throws a head is P. Sorry about the dog there. Then let's imagine it wasn't P. Let's imagine it was just a regular number, or normally with a probability be a fraction. So if the probability was going to be remember it's biased, yeah, so it's not a half. If the probability was 2/3 that it was going to get a head, what would the probability be? It would be a tail. Hopefully thinking, oh, that would be a third. How did you do that? Well, you went 1 take away 2/3. Okay. Give me another example. If the probability was going to be 1/4 that he gets a head, then this would be 3/4, because you know that it's going to be 1. It's going to be certain to be one of these two things. Therefore, these two have got to add up to 1. So probability he throws a tail is 1 minus P. Okay, and so we can actually now add, now we know this, we can say, okay, well, the probability that was a P, that would be a 1 minus P, and this would be a P, and this would be a 1 minus P. Well, how do we work out probabilities along this? Well, when you're going along the arms, you just multiply, okay? So this event is going to be P times, so that's actually P 1 minus P. Okay, just multiplying these two probabilities together. And to get this one, okay, that is also P times 1 minus P. Now, it could be this one, or it could be this one. And if it's this one or this one, you add. In other words, we're going to get 2P. We get 2 lots of this. 2 lots of this. So I've got that this would be 2 lots. I'll just see if I can write it there. 2P 1 minus P. Okay, and that they've told us that that is equal to 8/25 from this bit up here. And now I'm going to, because they in their expression here, their equation here rather, they haven't got any fraction. So let's multiply everything by 25, and if I do that, okay, I'm going to get 50. I'm just trying to make sure you can see what I'm doing. So let's just give myself a bit more space. So I'm going to get right over here 50. Okay, P 1 minus P is equal to 8. Then I'm going to multiply out. So get 50P minus 50P squared equals 8. Then their P squared is positive, so I'm going to move that over there. I'm going to move that over there, and that's going to give me 0 equals 50P squared, okay, minus 50P plus 8. And then finally I will divide everything by 2, okay, and that gives me 0 equals 25P squared minus 25P plus 4, which is the answer they required.